Hi, hello everyone. This is Vijayan from EC department. Uh, Today I'm going to present a short video tutorial on ARM processor and peripherals. Under this topic, we will see ARM architecture, the background, and how it evolved, and finally we will discuss the architecture. So the topics covered are ARM series of microcontrollers and how it evolved and its important features. So now let us go through the slides. Before getting to the ARM architecture, uh, I need to discuss 2 points about this CPU architecture, which you might already studied in your previous class. So the CPU architectures are broadly classified into two types. One is one human architecture and another one is hardware architecture. As usual, we know that in the one human architecture, the instructions and the data are stored in the same memory. So this is the advantage of one human architecture. So this model is followed in all the conventional computing systems. On the contrary, this hardware architecture, instructions and data are stored in separate memories. You can see it here. So separate memories for data and instructions, right? And this mechanism, this process is mainly used in the embedded system microcontrollers. So this type of architecture is being nowadays used in all the modern embedded system devices. So the another advantage is instructions are stored in ROM, permanent, while temporary data are stored in RAM, random access memory. So this advantage is utilized in ASIC processor, ASIC, application specific integrated circuit processors. Okay, so this is the two broadly classification of CPU architecture, one human and hardware. So now let us discuss about this ARM microcontroller. When we discuss the background, so how when and how it evolved in that microcontroller processors category. It was developed in 1983 by R.M.K Computers. You can see that R.M.K company and its icon on the right top of this slide. So the main purpose is to replace that 8-bit microprocessor 6502, which were used in that BBC computers. So they developed that BBC computers. In that computers, they used a 8-bit microprocessor 6502. So they want to replace this one. So they came with that idea of RISC processors. So they developed the ARM RISC processors in 1990. So this Macron computers, they initially they started and afterwards Apple and VLSI companies, they also started to use this RISC type of processors. So this is the background of the evolution of the ARM processor. And why do we need to talk about ARM? Because in all the modern mobile phones, modern devices, they are operated with low power and they have to give good performance. So we are in need of low power devices, and also with this low power consumption, they have to do good performance. The devices has to do good performance. So for low power consumption, battery is enough. So since we are in demand of low power devices, and they have to give high performance means ARM is the best option. ARM processors are the best option. So that's why ARM are in great demand in the market, embedded system devices market. If you see the application, most of the mobile phones, they use ARM processors, and digital media, music players, gaming systems, and even hardware, hard drives, they use nowadays they are using ARM processors. For example, as mentioned in this slide, ARM7 is used in iPod. ARM9 processors are used in BenQ Sony Ericsson mobiles, and ARM11 is used in Apple iPhone, Nokia processors. About ARM processors, uh, it's a simple computing, RISC-based architecture with powerful design. Design means low power consumption with high efficiency. Okay. Uh, so ARM processors family, the ARM processor like 9, 10, 11, they all share the similar design principles and a common instruction set. So you can carry out the common instructions in ARM9 also, ARM7 also, and also ARM11 also, because they share the same design principles and also common instruction sets are available. Even in the next version also, you can utilize that common that instruction set which are used in previous versions. So the basic why we are telling about this design principle means uh, they have small processor. They are designed for low power consumption. The small processors are designed for low power consumption, and with the size, even though the size are small, it is the RISC instruction sets are packed in that small size and with memory and with the advantage of physical size, small physical size. So that's why here we have mentioned high code density means even with the limited memory capacity and if small size of that processor, you can write uh, good codes. You can write good instruction set and packed instruction set. We can do it even with the limitations of physical size. And also it has the capability to interface with the slow and low cost memory devices. Because of this reduced size of the processor, we can accommodate more peripherals in that board along with this RISC processor, along with it with this ARM processors. So this is the main advantage of this ARM processor. It's a RISC-based architecture, reduced instruction set computing based architecture with powerful designs. You can carry out the instructions on all the versions from previous version to the upcoming versions also you can use the same instruction set. And also it is designed to handle low power devices and to give high performance. It has the advantage of small size and the memory can be fully utilized to write the code, and it can interface with other peripherals which are having low memory also memory capacity, and it can accommodate more number of peripherals along with this with along with in that same board. Now we can move on to the next slide. These are the popular ARM architectures: ARM7, ARM9, and ARM10. You can see the pipeline stages for ARM7. Why we need pipeline means within single clock we can this fetch, decode, and execute instructions can be completed within a single clock. So ARM7 has that capability, and also it has low power consumption and high code density can be done, and most widely used for low-end systems. ARM9, it is compatible with ARM7, It has 5 stages, pipeline stages, that is fetch, decode, execute, memory, and write. And another advantage is it has a separate memory for these instructions and data. And for ARM10, you have 6 stages, that is fetch, issue, decode, execute, memory, and write. All 6 stages can be done in a single cycle execution. Now this ARM is now we already know this ARM is based on RISC architecture. Okay, so the major features, the design features, reduced instruction set, and it can execute the instructions within a single cycle, and it is also a fixed length of instructions. So as you know, pipeline within a single cycle, the 3 stages or 6 stages or 5 stages can be done, that we discussed in the last slide, previous slide. And register, it has more number of registers, general purpose registers, and also it has a concept called load store architecture, where instructions work on registers. Instructions can carry out the data processing on the registers. So load and store instructions are used to transfer the data from and to memory. This is the very good advantage of ARM architecture, wherein the performance can be improved a lot. So this is already we have discussed about this memory mapped IO in further videos. So this is a typical architecture of this ARM7. You can see here the register banks, data are stored here, and data can be directly get into this ALU unit through this bus. And if we need the data to be multiplied or to be shifted, it also possible using this multiplier block and shift barrel shift register, and the data is given to ALU. You have this address bus here and data bus here, and also see here read and write data operations can be done, and instruction decode, separate instruction decoder is here to decode the complex instructions, maybe in 2 cycles. So normally ARM supports single cycle instructions. If there is any complex instructions are there for processing, it can be done in 2 cycles. Okay, so very easy to remember this architecture. So in coming video lectures, we will discuss more about the other type of architectures and instruction sets we will look into in the coming videos. Thank you.